finish this one. Any questions so far? So far, so good? So everything left has an h in it. I guess the limit is h squared to 0 of h times 2x plus h minus 3. At this point, we're doing this, and you're like, well, why do we do all that work? Today, we're going to learn what we're doing here. Why it's so important that your pre-cal teacher made you do it, and I made you do it. Where that importance of it. This second question asks you to find the average rate of change in the following lines. What is an average rate of change? Slope. So that question will be on the AP. It still means slope on the AP. It's amazing. They ask you Algebra 1 questions on the AP exam. Okay, so the average rate of change, this is 1. Okay. Correct me if I'm wrong. Let's see, like there, there. What did you say? Maybe 5. Something like that. If we're off a little arc. But how am I getting those? Rise over run, right? So I'm going up 5, left 1. If you think it's 6, okay, you're right. Alright. What are this one? Let's try that again. What about a vertical one? Oh wait, that's not vertical, I lied. I don't know. That one's a bad one. I should have done a better picture. Something like that. Why is it a bad picture? Why is it a hard one? There's no points that it hits nicely, so it's a little hard to tell. But I'm happy with it. This one has 2. It's maybe 1/10. And what is the slope of a vertical line? So that's how you find slope. Today we're going to talk about derivatives. So you remember there are 3 big concepts in Cal 1. Limits. We're done with limits. You've learned them all. Okay? 2 is derivatives. 3 is integral. So we're going to spend the rest of this semester on derivatives. So it's a really big concept. So the question is, what is a derivative? Well, we just finished finding average rate of change. Yes. This is unique. We just finished finding average rate of change. So I'm going to bring up a little. So I pulled up a little picture here of 2 points, x and x plus h. If I wanted to find the slope between those 2 points, how would you do it? How do you find slope with 2 points? Y2. So y2 would be f of x plus h. Would you agree? Whatever that is. x plus h, x2 minus x1 and x2 is x plus h. Agreed? What happens to those two x's? And what do you get? So what is this big formula really? Before that. It's just the slope between two completely generic points, x and x plus h, right? So that big weird thing you've been doing for a long time is just a generic slope between any two points on the curve, x and x plus h. Now, for fun, in calculus, we threw a limit in front of it. What in the world would that do to these 2 points? If h approaches 0, what is h on this picture? One's x and the other one is x plus h. What is h? Here's x. Here's x plus h. What's h? Okay, this is x and this is x plus 3. What's that? Okay, 3 would be h, right? It would be the distance between the 2 points. Right? Distance between the 2 points. So we're looking at the limit as the distance between the 2 points goes to 0. Okay, let's look at how that looks. So if I take this point and get closer and closer and closer and closer to the other one, what happens when I actually get to the other one? On my picture. The line went away because I made the line with 2 points, right? A line through 2 points on a curve is called a secant line. You probably heard that in geometry. You might want to write that down. A line between 2 points on a curve is called a secant line. But I don't want the slope of a secant line. I want the slope right here. Right there at that point. That took hundreds and hundreds of years to figure out how to find it. It involves a limit, right? Because I need the limit as h approaches 0. When I do that, I get the instantaneous rate of change, or the rate of change at a point. Instead of a secant line, I get what's called a, does anyone know from geometry? If I touch at one point. Say that louder, Grant. A tangent line. I get a tangent line. So the slope of the tangent line is this weird limit thing. Now, at this point, you're probably like, okay, that's great. Well, what does this mean for you? The slope of a tangent line is the instantaneous rate of change. So if I'm driving from here to Fort Smith, and I get pulled over.
Teachers and students, have your attention, please. Any grade G through M. Report to the back for your picture or retake. G through M.
Does the police officer care about my average rate of change? No. What does he care about? Right now, what's happening? Would you agree that in a lot of cases, that's what we care about? What's happening right now, right? Especially in high school, right? That's all that matters is today. I'm just teasing, really. But anyway, so instantaneous rate of change is a very important concept, and the derivative gives you that, and it's that weird limit thing that you've been looking at. So we answered those questions earlier. Let's see. What would the slope of a secant line be? This is the slope of a secant line. Right? No limit. It's just the slope between 2 points. The slope of a tangent line would be the limit as h approaches 0 of f of x plus h minus f of x. All over h. So that is the slope of a tangent line. That is a derivative. That is big news. That's important. what we're going to spend the rest of this semester on. So September to December. It's all about that thing. Which brings us to the actual definition of the derivative. The derivative of a function is a slope of the curve at a single point. And I showed you where it came from on the other slide. But f prime of x, f with a little tick mark is red, f prime of x is one notation. Another notation is dy over dx. Those both stand for derivative. Is the limit as h equals to 0 of f of x plus h minus f of x all over h. Just a little history on the two notations. Calculus was discovered / invented, whatever you want. You could debate about that either way. By two different guys at almost the exact same time. There's, of course, quite a few accusations of plagiarism and whatnot. But essentially, history says it was developed maybe independently by two different people at around the same time in history. And so we have two different notations that pop up a lot. One of them comes from Isaac Newton. In his definitions, he talked about fluxions and weird stuff. But anyway, he used prime notation, f prime of x standing for the derivative. The other guy, whose name was Leibniz.
Teachers, come over your attention, please. We need the following students to report to the task. If they are not in class today, would you please let me know? Shelby Bennett, Will Fitzgerald, Justin Finn, Kayla Dela Cruz, Jacob Colley, Paige Cole, and Joseph Bradshaw. They need to report to the task.
The other notation, Leibniz notation, he was a German guy. Newton used calculus for his, Newton, right? For his physics stuff. You kind of heard of him. He's kind of an important guy. And he developed calculus because he needed it to explain physics in the real world. So we'll talk about that as we get into applications. Leibniz did it more for the pure joy of mathematics. And so his notation actually is a little bit better mathematically, but Newton's is a little easier, nicer. Leibniz used dy over dx. He used the d to represent a differential, a teeny tiny change in x over a teeny tiny change in y over a teeny tiny change in x. It kind of mimics the delta y delta x notation that we've seen before. So anyway, that's Leibniz notation. We'll talk about both as we go. We will use both interchangeably. And that is a derivative. So I want to find the derivative, and right now all we have is this big long definition. As you can imagine, I've just talked about how important derivatives are. We hope to find shortcuts. Over the next 2 days, your goal is to watch everything I do closely and see if you can figure out a shortcut. Those of you who know the shortcut are to keep your mouth closed at all times. So you're looking for shortcuts because we hope to not have to do that big long limit definition forever. We'll do it as long as we can. Hopefully. So the first one, what is a derivative? The slope, right? What is this? What is f of x equals 7? A horizontal line? What better we give as our answer? What should the answer be? 0, right? Because the slope of a horizontal line is 0. So let's try it. I know that f prime of x is the limit as h approaches 0 of f of x plus h minus f of x all over h. What is f of anything if our function is 7? What's f of 10? What's f of a million? What's f of smiley face? So what's f of x plus h? 7. What's f of x? is 0, but 7 minus 7 is 0. Would you agree? So that limit is 0. Does that make sense? Would you agree that would have been probably the hardest? If I had put that on last test, most of you would have missed it. Even though it was really, really easy. Because it was almost so easy it was hard. But if you think back to what it means to be a slope, it makes perfect sense. So f prime of x is 0. What should we get on this one? If you know the derivative is a slope, what should you get? Negative 8? Everyone agree? We think we should get negative 8. Why? Y equals mx plus b. The slope is m. We should get negative 8. I am going a little bit faster through these f of x plus h things. You've already been tested over it once. Negative 8h divided by h is, I know it's like we've just changed the world, right? Of course we got negative 8. At this point, I hope you're going, well, why would we do this? It just gives you a slope. So the derivative is negative 8. Now, so I did it first to prove to you that this does, in fact, find its slope. Why is it more important on the next one than the last two? I don't know the slope. And what do I know about the slope on a quadratic? What's going to happen? The slope, it's going to change. Would you agree? The slope is going to change as I move along the curve. Well, let's see what that looks like in an answer. So your homework tonight, you're going to have to do some limits the long way, or some derivatives the long way. Again, every derivative you do, look and see if you can develop patterns. It'll take you a little bit. It won't pop out today, probably, but in a couple of days. And don't cheat. Don't ask a friend. Think about it. In college, we have a college professor. They will be very picky about correct mathematical writing. And when you write something right below something, you're essentially saying it's equal to it, generally. And if you leave the limit off, you've lost the it's teaching you how to math a little more precise. On AP, they will expect that level of correctness. Now, are you ever going to have to do this on AP? No. Oh, maybe not. Probably. The x squareds cancel, the 2's cancel, and the negative x's cancel. Everything else has an h in it. 2x plus h. Plus h. Yeah. Oh, plus 1. Because I'm back to the h already. But right. It helped if I crossed things out. The h's cancel, and then the limit as h approaches 0. approaches 0 of x plus h minus 3 minus the square root of x minus 3 all over h. Add derivative f of x plus h minus f of x all over h. Yeah, what does this mean I have to do? Good. This is just more limit practice at this point, right? I have to multiply by conjugate. I get the limit as h approaches 0 of x plus h minus 3 minus x minus 3. Don't forget your parentheses on that. And on the bottom, I'm going to leave it factored. What happens on the top? Everything cancels except for the h. The h's now cancel, so I'm just left with a 1 on top. And now can I plug in 0 for h? So I get 1 over the square root of x minus 3 plus the square root of x minus 3. Or 1 over 2 square roots of x minus 3.
I'm sorry about that.
Sure. Thank you. It is. Or you could call that dy dx also. Yes. So that's just another limit along that sequence. And if you had stopped here, that would have been correct as well. Just a different way around. So this is the roots. Any questions about that?
So we don't have to have x out of our answer. Because like on the second one that we did, we just found the slope or whatever, but then on the one that we had the x squared plus x times 2, then we had x and the answer. But that answer was like that other one, so we don't have to find like the slope would be 2 or whatever.
Right. And so on this one, whoops.
It's almost like h.
I just got to the end somehow. Here we go. Oh, I guess it added a fixture again. So on this one, we got 2x minus 1, and that's because the slope changed as we moved along the curve. But on this one, we just got negative 8 because it's a line. So anywhere on that line, the slope is negative 8. Does that make sense? And so on a square root.
Teachers and students, have your attention, please. M through Z for 10th, 11th, and 12th grade. Report to the pack. M through Z.
Okay. So find the slope of the tangent line of the graph at the given point, and then find the equation of the tangent line. So I'm going to use algebra 1 here. What do I need to write the equation of a line? Two things I need. A slope. A y-intercept, great. Do I have to have a y-intercept? A slope and is you will only have to do this the long way for a couple more days. And on the test.
What's the next test?
I have to look at my calendar. It's a little ways out. The next test does have the mastery exam right before it. There is a mastery exam coming out. Two-tieredly. It will be before the finals. But it won't be this week or next. The X-squareds cancel. The 9s cancel. Are y'all getting good at these? Say that again. Because I want the slope. And so I know the derivative is the slope. And I can plug in 0 for h, and so what do I get? 2x. So the derivative is 2x. That's great. That's not a slope. And at the point -1, -8, I should be able to find the slope. Well, what would the slope at -1 be? How could I find it? You agree the slope at -1 would be -2? We've never been able to find that before. No, but we just found the slope at -1. Do I have a y value for a point? What is it? -8. Do I have a slope? Do I have an x value? So that is the equation of the tangent line to that graph at -1, -8. So I have to actually graph the tangent line. We'll spend more time on tangent lines later. One other piece of information for you, and then we will finish. You have heard the word differentiability on weird homework assignments, right? And I just said, we'll learn about that later. To be differentiable means that we can take a derivative. We can find a derivative of something. So that's what it means to be differentiable. What you need to know is, when can you not take a derivative? That's the big question is, when can you not take a derivative? There are 3 special cases when you can't take a derivative. And I'll show you why. I want you to do this homework by tomorrow. But if you do have a lingering question, we won't actually grade this until Friday. Is that the next day? Tomorrow's Thursday. So I want it to be done tomorrow. It's not a 2-day assignment necessarily. You will get a new assignment tomorrow. I just want to give you a little leeway day in case you have questions, because we covered a lot of material today. So tomorrow will be a continuation day. So if there's a couple you don't understand, don't stress about them. We'll pick it up tomorrow. Okay, I'm going to pull up a visual. If I look at this graph, if I were to draw a tangent line on it, what would the slope of the tangent line be coming from this side? -1, right? What would the slope be coming from this side? +1, right? interval. At 0. Now, anywhere else, can we find the derivative? It's 1 over here, negative 1 over here. But at 0, it's a problem because the left and right hand limits approach a different thing. A cusp is it's an identical reason. A cusp is a sharp corner. It just is a little different picture. A sharp corner can be any time the slopes change instantly like that. A cusp makes this little curve thing. At the cusp, the derivative is undefined. And the last one is at what's called a vertical tangent. And I have a picture here. This is a cube root function, I believe. So I've got it here. If I look at a tangent line, so I take a line, and I move it along the curve, what happens right at 0? That tangent line is vertical, isn't it? And what's the slope of a vertical line? So if you have a vertical tangent line, that's the third place where the derivative does not exist. There is actually a fourth place, and it's not listed on here. But the fourth time that the derivative doesn't exist is at any discontinuity. So that is number 4. Any time the function is not continuous, there is no derivative there. Would that make sense? Yeah, it'd be hard to find a slope at a point if it's not connected to another point. So those are 4 cases where the derivative does not exist. Okay, we'll talk about that tomorrow. We'll pick the rest up tomorrow. Any questions about a derivative? So you've been doing the